Yo. Alright, so just to kind of reiterate the problem. So this is over here is what we want. So we have a road from this point. Shit. It starts at this point, ends at this point over here. Um, and we want the border lines on the, like, I guess, right and left of the road to be parallel to the road, but also we want them to be in like the same plane as which the road starts at. So um, basically, this should make a 90-degree angle with the center road, and all of them should make basically 90-degree angles here. And so, kind of figuring out what point this starts at requires a bit of trig, just because you can see in this image over here, like this is where the road starts at, right? And so if you go just like the offset to the left and to the right of that, when the road is diagonal, you're basically not going to get the desired behavior. You're going to get a weird looking road where they don't all fall in the same plane that's expected, like this. So what we do here is just a bit of math to figure out what those 2 points are. These 2 points over here, I've labeled them P1 and P2. So you can see theta r represents the angle between like the horizontal axis from P and the actual road. So we'll call that theta r for road. And so since you know there's a 90 degree here shown, this angle over here, the angle between the horizontal and where the point is 90 minus theta r. So now what we want to do is find the height and find the width, like how x distance. So we'll call both of those delta y. This is delta y right here, and this is delta x. So now we can label this point x1. So x1 over here is equal to 10, which is the hypotenuse of this triangle. Now let's draw in the triangle here. Yeah, you can like imagine a triangle here. So 10 sine of 90 minus theta r, which is this angle. That's going to be y1, which is shown right here. That's going to be delta y. And so y1 is just going to be whatever that delta is plus the y value of this point, right? And so same thing for x1, that is just going to be this x value of this point plus whatever delta x is here, right? So p1 is equal to basically x1 comma y1. And so p2 is this point is the same thing, right? It's just now taking p and subtracting delta x instead. And then y2 is the same thing. It's just taking the y value of p and subtracting delta y, and you'll arrive at this point. So now these are the starting points of the road, and you make them the same distance as whatever the road was. Yeah. So the logic in the code is a little different, and that's because right here when we do these calculations, we're assuming like the addition and subtraction calculations here, we're assuming that, like, you know, it's like we're assuming x to the right and y is up. But what's happening actually in the code is, as he pointed out last time, x is to the right and negative y is up, or basically y is going down. Negative y. So, yeah. I hope this helps. Let me know if any of this wasn't clear. As you can see, I had some scratches over here and shit. But I think this should clarify things. Do I have anything else? Oh, yeah. I wanted to just remind you of this quickly. You might be curious as to where the cos of 90 minus theta r and sine of 90 minus theta r came from. Well, if you look at a right angle triangle, oops, this should be a right angle. You remember from trig, so sine of theta is opposite over hypotenuse, so it's b over h. Cos of theta is adjacent over hypotenuse, so a over h. And so if you rearrange for a and b, you'll get that b is equal to h sine theta, so the hypotenuse sine theta. That's the same argument we're applying here. The hypotenuse is the road width, and then sine of theta, sine of the angle, in this case the angle is 90 minus theta r. So that's where we get this expression from, these two expressions. And to get theta r in the first place, since you don't know what that is, you apply the arctan function. So that means you take the tan inverse of both sides here. Tan inverse of this, and then tan inverse of this. Looks so fucking bad. Shit. So then theta is the tan inverse of b over a. Yep. So that's how you get theta r in the first place. So that is how we got theta r. Okay, that should hopefully clarify everything. Yeah, again, just message me if anything's unclear. Peace.